Good evening, sir.
फिर बोलाना पैर रखने वाला। गुड इवनिंग धैर्य। गुड इवनिंग सुमुख।
Good evening, sir.
सुमुख गुड इवनिंग।
Good evening, sir.
Good evening, sir.
Okay, good evening. So I think today we have our physics class. Yes.
Yes, sir.
Okay. Good evening, Moksha.
Sir,
Yes.
sir, I actually wasn't there for the last class, like last Saturday, I guess, because I had my exams. Like, what did you do?
Okay. So in the last class we did electric circuit, how to arrange an electric circuit, and I think we studied about current and potential. Ohm's law. Ohm's law was the topic that we did in the last class. So we'll just go a little bit of review with the Ohm's law and then we can continue further.
Sir,
Yes.
this week exam I'll have science, sir. Sir, and physics chapter light, sir.
Sir,
Okay.
sir, I'm sending you my question paper.
What happened?
Sir, I'm sending you my question paper now.
What question paper you want?
Sir, my question papers. I had exam this week.
Okay, okay. So share the question paper to me. We'll be discussing that question. Right?
Sir, I have a doubt, sir.
Okay, you have a doubt over there?
Yes, sir, on concave. Sir, rule for convex, say concave lens, sir. Rules for drawing that convex, say concave lens, sir.
Rules for concave lens. Rules for drawing images for concave lens or rules for Cartesian system?
Sir, drawing that image, sir.
Okay. So just can you send the question?
Now I do not have that question, sir. I just remember that question, sir.
Okay, I think I got the question here. Which question are you talking of? I've got one question paper.
Sir, we both are different schools, sir.
Okay. See, what I guess, since you are asking, so what I guess you are asking is, like, what will be the rules for forming the image by a convex mirror? Convex
Concave
lens.
lens, sir.
Concave lens. Okay.
Yes,
So
sir.
this one. Rules for drawing a ray diagram.
Sir, in the question paper which I sent, I have a doubt, sir.
Okay, okay. So just I'll be clearing your doubts. Just one minute. First, let me clear this. Rules for drawing a ray diagram of concave lens, right?
Yes, sir.
See, the rules, they are the same rules. You have your first rule as the ray of light that passes parallel to principal axis. Principal axis appear to pass through focus. It doesn't pass through focus, but it appear to pass through focus. This is one of the rules. The second rule is the same one as the optic center. So you have the ray of light.
Good evening, sir.
Yeah, good evening. So the ray of light passing through optic center, the ray of light passing through optic center passes undeviated. Okay. So with these rules, we are able to draw the ray diagram.
Sir, these are applicable for all, sir.
Yes, what these are?
So are these applicable for including those mirrors also, sir?
Pardon again, I'm not getting the voice. Or be louder, just be a little louder.
Sir, are these applicable for all like mirrors and lenses?
You just need to make a little bit of language changes over. For example, if you're making this change for a convex lens, so instead of writing appear to pass, you write it will pass through focus.
Okay, sir.
Okay. If you are writing it for a mirror, so for the concave mirror again, it will be passed through focus. For a convex mirror, it will appear to pass through focus. For a convex mirror, it's almost the same. Here you will be writing, instead of writing the optic center, you will write the center of curvature. The ray of light that passes through center of curvature bounces back along the same path,
So could you repeat?
right? The ray of light going to the center of curvature or passing through center of curvature bounces back along the same path. So these two rules which I have written over here, they can be described something like this. The diagram for it can be made like this. So this is one of the lens. Let's say this is your focus f1. This is 2f1. Here you have f2 and 2f. So if you have a ray of light passing parallel to the principal axis, so this ray of light will appear to pass through this focus and pass like this. So the ray of light, it passes something like this and it appear to pass through focus. Okay. So this is the first rule, coming parallel and going deviated like this. For the second rule, it's like this. So for the second one, you have your optic center, f1, 2f1. So if you have a ray of light that passes through the optic center, if you have a ray of light that passes through the optic center, so it passes undeviated. The ray of light will pass undeviated. There will not be any deviation in the ray of light. Got it?
And sir, one doubt, sir. Sir,
Yes.
for this is for both convex mirror and concave lens, sir. These two.
But yeah, it is for both.
Okay, sir. And one more doubt, sir. Sir, what is the second point for this convex lens and concave mirror, sir?
Okay, for the convex lens and concave lens, if you are talking for the lens, it will remain the same.
No, sir. The second point, no, sir.
Yes, the
What
second point, it will remain the same. The ray
Okay,
of
sir.
light passing through the optic center passes undeviated.
Okay, sir.
If you are talking for the mirror, then as we know that in case of mirror, there is no optic center. There is pole and there is center of curvature, right?
Yes, sir.
So we talk in terms of pole and center of curvature.
Okay, sir. So the second rule for both the mirrors is ray of light going to COC, sorry, center of
Yeah.
curvature bounces back on same path.
Yeah. So this
Okay,
is for both lenses. And this one is for a concave lens. If you want to make it for a convex lens, so for convex lens, you just need to cut this. Appear to you'll cut, you'll get it for the convex lens.
Okay.
Now another doubt has been sent out from a question paper only. Who has sent the doubt? Yeah, Huria. Yes, Huria, what is your doubt?
Just a minute, sir. Sir, I asked the
Yes, what is the doubt?
yes, sir. Sir, can you once explain the Snell's law?
Okay.
And the question below it.
Okay. So first of all, let's try to understand the Snell's law. It states that the ratio of sine of angle of incidence to the ratio of si- sine of angle of refraction is a constant. So what is Snell's law? As per the Snell's law, the ratio of sine of angle of incidence to the ratio of sine of angle of refraction is a constant and is equal to the refractive index of the given pair of media. Got it? So see, as I hope the statement is clear to everyone, and let us see what does it mean. You have here two media. So let this line be the interface between the two media. Let this be your medium 1 and let this be your medium 2. Suppose a ray of light passing from medium 1, passing through medium 1, comes in contact with this interface and then it passes to medium 2. So suppose in medium 1 it had its velocity v1 and in medium 2 it had its velocity v2. So at the point of incidence where the ray of light was incident will draw perpendicular to this line. The perpendicular to this line will be the normal to the surface. So hence we have got the normal to the surface and this angle is the angle of incidence. This is our angle of incidence and the angle formed between the refracted ray and normal is the angle of refraction. Got it?
Yes, sir.
Now
Sir,
what does this? Yes.
sir, two more doubts, right, sir?
Okay. What is the doubt?
Sir, the sir, I had asked a question, sir. If can a plane mirror called be a spherical mirror? If yes, why?
Yeah, a plane mirror can be called as a spherical mirror of infinite radius of curvature.
On
Okay. See, if you have a infinite radius of curvature, so its focal length will also become infinite. It's something like this. See, okay. Let's give me an example for this one. Okay, so here I've taken a circle over here. Can everyone see the circle?
Yes, sir.
yes, sir.
Yes, sir.
Yes, sir.
Okay, so for this circle, I am making it bigger now.
Yes, sir.
So I'm making it still bigger. So this much I have made it bigger. Now, so what do you think if I cut a small portion of the circle from here to here? If I look up at just this much portion of the circle, doesn't it appear to be a straight line?
It appears, sir.
Yes, sir.
It
It appears to be, sir.
It
No,
appears
sir.
to be Okay, to you it doesn't appear to be straight line. Okay. So, and another thing regarding this. Okay, if someone says that yes, it doesn't appear to be a straight line. So can we all agree that Earth is round, Earth is sphere?
Yes, sir. Yes.
So why?
Yes, sir.
Okay, uh, Earth
Can
is
you again?
sphere. Okay, Earth is sphere. So do we see everywhere around us flat? Do we
Yes,
see
sir.
flat?
Yes, sir.
Yeah.
Yes, sir.
So why do we see flat fields? Why not spherical fields?
Sir, only because the sphere is too large and you only see the part of it.
Yes, if you see a very small part of it, so that part will appear to you as a straight line. Or if you are taking a big circle, if you observe a small part of it, it will appear to you as a flat surface. So in the same way, if you have a plane mirror, so we can consider a plane mirror to be a part of very big sphere. Okay, a sphere which has its radius of curvature to be infinite. Got it? Okay, so hence we can call a plane mirror to be a spherical mirror of infinite radius. Any other doubts?
So that's all we can write now, sir.
Yeah, that's what, that's all.
And one more doubt, sir.
Sir,
Yes.
Sir, that there was a question, sir. How can plane mirror and the spherical, that is convex and concave mirror, be distinguished without touching them?
Yeah, by the formation of images. Okay, see, consider this one. You have a plane mirror and you take a concave mirror, you take a convex mirror. So without touching it, how can we identify them? So if you keep an object in front of all, so here I keep an object, here also I keep an object, and here also I keep an object. Okay, so how will I be able to identify? Here the image will be, here I will always obtain the image of same size, right? In a plane mirror, I will get the image of same size, virtual and erect, right? For all positions of object. So wherever I keep the object, anywhere if I keep the object, I will be getting here same size, virtual, erect image for the object. For the concave mirror, if I get a virtual image, so my virtual image will be enlarged. And if I get a real image, so it will be inverted. Right? So mirror can be identified by the nature of the images which they form. If it forms a real image, then it is a concave mirror. If it forms a virtual image, so if the virtual image is of the same size, it will be a plane mirror. And if the virtual image is smaller than the object, then it is a convex mirror. Right? Here you have the image is virtual and smaller than object. Got it?
Okay, sir. So I should only write that formation by the formation of images.
No, you need to describe all this. You need to
Okay, sir.
write that in the plane mirror, wherever you keep the object, the image formed will be of the same height as the object. Okay, but the mirror that forms real images or forms virtual and enlarged images will be a concave mirror. The mirror that forms virtual and smaller images, that will be a convex.
Okay, sir.
Any other doubts?
one doubt, sir.
Yes, what is the doubt?
I sent you the question paper, no, sir.
Okay, just one minute. Let me open up the question paper. Okay, so your doubt is on the first page or the second page?
So the fifth question and the sixth question.
Fifth and sixth questions, right?
Yes, sir.
Uh, I don't know fifth or sixth. Is it this optical bench like thing?
Yes.
Just 1 minute. I'm just sharing the screen again. Wait. So just see. Okay, which are you talking of this question?
Yes, sir. The before page.
Okay, the second page you are talking about. This one. So are you talking of this one? Question sixth
No.
and fifth. Right.
I'm talking about the first one, sir.
Okay, this one.
Physics question.
Okay. Which one physics question?
So first page, sir. Not this one.
First, I got only these two papers. The one you have this one. You have
Sir,
sent this.
before that one.
Before that one, no question paper. I think I have received. Okay, this one. Yeah. So in this one, I want to see question 5. The power of combination of two lenses P and Q is 5D. If the focal length of P is 15 centimeter, state the nature and focal length of lens Y. Okay, so it's not Y. You have to find the focal length and nature of lens Q only. Right? That is, I think, a small typing error or typo that you can consider. So here, the power of combination, that is P1 plus P2, is given to us as 5, and we are given the focal length of P. So f of P is given to us as 15 centimeter. So hence power of P will be equal to 100 by f. Since if I'm taking this in centimeters, so it will be 100 by f. So I'll obtain 100 by 15, which I get 20 over 3. Right? So the power of this P is 20 by 3, which is 3.3. So put this P as 3.3D plus power of Q will be equal to 5. So Q will be equal to 5 minus 3.3, that you get as 1.7D. But so nature we have got, since we are getting a positive value of power, so the nature has to be,
Excuse me, sir.
yes.
Sir, 20 divided by 3 is 6.66.
Oh, sorry. Just 1 minute. Right. Okay, you get 6, not 3.3, it's 6.6. Thank you. So you get 6.60, then you will be getting a negative value, right? So 5 minus 6.6 will make it negative 1.6. That's okay. So since we are getting the power as negative, so the lens should be a concave lens.
Okay.
It has to be a concave lens, and its focal length can be found out by the formula 1 over T, or 100 over power. So 100 over negative 1.6 will give the focal length. Got it? Any other doubts?
Sir, also the sixth question, sir.
Okay, this is the fifth one. You are saying for sixth one?
Yes,
Sir,
sir.
could you once again show the solution?
Yes. Yeah.
Sir, I did not understand this question, sir.
Which part didn't you get?
I
See,
said,
this one is the formula for power of combination, right?
yes, sir.
So since the power of combination is given as 5D, so if I add the powers of P and Q, I'll be getting 5, right?
Yes, sir.
Okay. So here I have found out the power of P. Since focal length of P is given as 15 centimeter, so by using the formula of power, I obtained the power of P, right? The formula of power is 1 by F. If you are taking F in meters, so it will be 1 by F. Or if you are taking F in centimeter, so power is given as 100 over F, if F is in centimeter. So I'm taking F in centimeter, so that is why I'm getting 100 by F. So it's 100 by 15. If you solve 100 by 15, that is 20 by 3, which is 6.6. What is this one?
Sir, how did 20 by 2, sir?
20 by 3, not 20 by 2.
Oh, okay, sir.
Okay, you cancel this by 5, you get 20, and here you get 3. So it's 20 by 3. I do make calculation mistakes, but not every time. Okay. So got it now?
Yes, sir.
So now just put here at the place of power of P, I put 6.6 and I obtain the power of Q. So power of Q is 5 minus 6.6, which is negative 1.6. Since I'm getting a negative power, so negative power means the lens is a concave lens. And again, if I want to find out the focal length, so again I use the same formula, power equals to 1 by F.
Sir, nature will be that real inverted.
No, they are asking the nature of lens. So when you are asking the nature of the lens, so nature of lens is either converging or diverging.
Okay, sir.
So what is the nature of this lens? Converging or diverging?
Diverging.
Yeah, it is a diverging lens. Right? So
Yes,
it's
sir.
a concave lens, or you can write it as a diverging lens. Okay, anything else?
No, sir.
Yeah, what happened? Okay, any other question now?
Question.
Just let me show. Which question you are talking of? Okay, Huria. Sorry, Huria, I couldn't take the last class. I was somewhere stuck in a traffic a long back. Like a long back means nearly about maybe it was about 50 kilometers where I was stuck. So it was impossible for me to not take the classes. The same class will be arranged on Sunday morning time, not the evening time. I'm informing everyone. Your class will be Sunday morning time.
Sir, at what time?
Time I will confirm tomorrow, but it will be in the morning time before 12 noon.
Sorry, sir, I would be not able to attend. I have a match.
Okay, so you can see the videos or whatever. At what time will you be available in the morning?
Sir, don't know.
So if anyone can, okay, anyone else will not be available?
Sir, I will be available at 11 to 12 or after 12.
Sir,
Okay,
from
so
what time I'll be available, sir?
okay, so I will try to arrange near about 10 or 11 a.m. Right?
10 I will not be free, sir.
Okay, what about 12? Shall I arrange at 12 now? 12 p.m. or 12 noon or 1 p.m.
12 is okay, sir. 12.
12 is okay,
12.
sir.
Okay, so I will try to arrange a class at about 12 noon, maybe 10 minutes before or 10 minutes earlier, after 10 minutes, 12:10 maybe, right? Okay, so this question is clear to everyone?
Yes, sir.
Yes, sir.
Okay, so any other doubts in it? Yes,
Yes, sir. Sixth question.
sixth question, right?
Yes, sir. This one.
So if you stand at a distance of 15 centimeter in front of a concave mirror of focal length 15 centimeter, what is the position and nature of your image? Draw a ray diagram for it. Okay. So if you just look up at the information given, you obtain that focal length is negative 15 centimeter. Since it's a concave mirror, so you write negative 15, and the image distance is also given as negative 15 centimeter. So even without solving, even without using the mirror formula, I will be able to obtain the image distance. Can anyone guess where will the image be formed for this case?
Infinity?
Sir, infinity.
Infinity. Yeah, since the object is placed at focus, so therefore the image is formed at infinite. Yeah. So here I get V equals to infinite. Then which ray diagram shall I draw for it?
The one where the object is standing at the focus.
Yeah, we'll draw the ray diagram for the object standing at focus. Then in the second one, 6B, in the setup shown below, the focal length of concave mirror is 4 centimeter. Where should the screen be placed on the scale to obtain a sharp image? So as you can see at the bottom, a scale has been provided. Okay. So on this scale, where should you place the screen? Okay. Where the object is located? Can I say that object distance is infinite? See, light from a distant object. So when you are getting
Yes, sir.
light from a distant object, then object distance is infinity. Then where is image formed?
Sir, focus.
Focus. And the distance of focus from the screen is 4 centimeter. See, the focal length is given as 4 centimeter. So my screen should be placed at a distance of 4 centimeter from this mirror. So it has to be 1, 2, 3, and 4. So I should be putting my screen at this point, right? And on the scale, I can read it to be 1. So where will I place the screen? The screen will be placed at 1 centimeter mark. Okay. Any other doubts?
No, sir.
Okay. Okay, so bye everyone. We'll see again. I think tomorrow also we have class.
Yes, sir.
Sir,
Yes. Yes.
over here I did not understand this question, sir. Why can't it be 9? Why only 1? Like, why is it going that side?
Okay. For the mirror, this is a concave mirror. And since real image is always formed in front of the mirror.
Okay, so we have to move towards the negative side. So 1.
Yeah. See, in the case of concave mirror, the real image is always formed in front of the mirror. So you have to move in front of the mirror. Okay. Had it been a lens, then you would be moving behind it here. Got it?
Okay, sir. Yes.
Okay. So bye all of you. See you
Sir,
again
one doubt I
tomorrow.
had,
Bye,
sir.
sir. Thanks.
Okay, what's your doubt?
Sir, how do you determine the position of that image in for mirrors, sir? Like, is it
Okay.
behind?
Okay, see, it is given that light is coming from a
No, sir,
distant
for
object.
A, sir, I'm asking for A.
Okay, for A. See, the focal length and object distance are same.
Yes, sir.
See, if you stand at a distance of 15 centimeter in front of a concave mirror, so if you are standing at a distance of 15 centimeter from a concave mirror, so your image will be formed at infinity. You are standing at focus.
Yes, sir.
The focus is 15 centimeter. So if you are
Yes, sir.
standing at focus, your image will be formed at infinity. Okay. Okay, so
So,
bye all of you.
so, sir,
Yes.
my image will be formed at infinity.
Yes.
Okay, sir.
Okay.
But how
So
will you draw the diagram, sir, then?
yeah, the diagram which we obtained for focus, the diagram drawn for image formation by concave mirror for object at focus.
Okay, sir.
Okay. by all of you. If your doubt is not clear, I will draw the diagram and share through the group. Okay.
Okay,
Okay.
sir.
Bye.
Thank you, sir.
Bye,
Okay,
sir.
bye.
Thank you, sir.
Okay, bye.